water to our society. Let's start the presentation. Bismillahirrahmanirrahim. Next. My today's topic, because I have limited time of 45 minutes, which has been allocated by the persons who have arranged this exhibition. In a short, I will covering the water treatment, filtration, membrane technology, ion exchange, and wastewater. In 45 minutes, I can just give you the overview of these technologies or the water situation. Later, we can have a webinars to understand each and every part of it. Next. Water, water is H2O. It has two hydrogen molecules and one oxygen molecule. Its atomic weight, molecular weight is around 18 grams per mole, and the angle between the hydrogen and the oxygen ion is 104.45 degree. Next. The sources of water. We have the sources of water. Surface water mainly and the groundwater. Groundwater comes from the streams, lakes, ponds, rivers, embedded reservoirs, and store rainwater. Sometimes we, in the desert areas, we have then catchment ponds where we store the rainwater. Next. Oh, why to treat the water? Basically, the treatment objective of different. First, the objective we consider is the drinking water. How to provide a safe drinking water to the human being and the society, so that, and the irrigation purpose. We treat for the water for the human and the agriculture purpose, and second purpose is for the industrial use. In the industrial use, we have a different requirement, like for the boiler, cooling tower, process water requirements, which creates the problem to the efficiencies of the various equipment. We have the total global water availability. 96.5% is the ocean water, and 0.9% is the saline water, and only 2.5% availability around the globe is of fresh water. And if we divide the fresh water, groundwater, surface water, and then we have the lakes, and you can see the distribution of the water available to us. Normally, the water usage, which is internationally envisaged, agriculture we use. In agriculture, we use 69% of the water. In industry, we use 23% of the water. And the domestic use for the human consumption is around 8%. Thermal power plants, the industrial water consumption. The major consumption of the water in the industry is in the thermal power plant, and manufacturing, engineering goods, pulp and paper, textile is the big consumer, steel, sugar, fertilizer, and other industrial equipment. You can see the segment which we have colored, and they give the percentage of water being used by the industry. Now we come to the domestic consumption. The most challenging question sometimes comes that how we should plan a facility for the domestic use of water, like when we are planning a town or the a city or a colony or a residential area. The total requirement considered for per capita. Per capita mean per person. The domestic requirement we consider normally internationally, that is 27 liter per head per day. And it's you can see its distribution. I will give you the better idea on the next slide. This is a domestic use 135 liters per head per day. Public use 15 and firefighting 15. Industrial use 50. Theft and wastage loss 55. Total per head consumption of the water which we plan for while developing a town or the city or the industry, that is around 270 liters per head. And there is a distribution of 135 liters, which is the domestic water consumption. And that is for the bathing is 55 liters, washing of clothes 20 liters, drinking 5 liters, cooking 5 liters, washing utensils 10 liters, washing houses 10 liters, and WC is 30 liters. Total the domestic consumption when you plan a house, then it is a 135 liter. This is the important data when you develop an industry or you develop a town, normally this type of information is very limitedly available on the government sites, which we use. Obviously, VASA, another department, will be having this information on the basis of which they plan their cities and the sewerage and the clean supply of clean drinking water. But these are the general norms which you can follow for planning your facilities for the water and wastewater treatment plants. Now, if you see the city water works, domestic use, you have 135 liters per capita per day, and industrial use 40, public use 27, fire demand and losses and that 54. That's again, this distribution leads to the fact that around 270 liters per capita per day water is consumed by the domestic application. And now, a little idea about this is the really available information which I'm sharing with you guys, so that you can have an idea for while uh, developing water distribution system or the water treatment system. That factory with bathrooms, we plan 45 liters per head per day. Factory without bathrooms, attached bath means common bathroom, then we have a 30 liters we plan per head. And in schools which have the day, only day schooling, that is 4 liter per head per day. And for the boarding school, it is again, it's the same figure, 135 liter per head per day. In the restaurant, we take the 70 liters of water per day per seat, per dining seats, whatever you say. And in the hotel, per bed, we take 180 liters per head per day, and the cinemas 50 liters per head per day. And now come to the hospitals. When we come to the hospital, up to 100 beds, there's a all requirement merged in this figure. Up to 100 bed hospitals, we design the based water treatment system based on the requirement that 34 liters per bed, and above 200 we have 450 liters. Why on the above 200 bed is the more requirement, because the infrastructure of that hospital is more, and they require the more water for the cleaning, gardening, and other things. And similarly, nurses' houses, when we plan, again 135 liter, which is our domestic requirement, which covers the drinking, cooking, bathing, and other uses. And for the hostel, again 135, same activities goes on. And for the offices, we plan 40 liters per head per day. This is a seasonal variation, demands and fluctuation of the water. When we plan a water treatment facility, this variation may be up to 150% of the average demand of the year. You should design the piping and the storage capacity accordingly. Sometimes you have 150% of average demand of the year. And why this variation? This depends upon on the daily and hourly flow, like general habitat of the people in Pakistan, warm countries, water we take maybe 2, 3 times a day, sometimes showers, and we are sweating, and we need to refresh ourselves. The water consumption in the warm area is more as compared to the cold area like Europe and America. And the climatic condition, obviously, water consumption also depends on the climatic conditions, weather conditions of the country, region, and around the globe. And if we talk about in the Pakistan or the globally, the peak hours. At peak hours, we observe when there is a schooling and office timing, 8 to 10 a.m. in the morning and 4 to 8 p.m. In the evening. They are the peak timings for the water consumption, and the water demand is high. Now we can characterize the water. We have the availability of the water, but how we can characterize them and distinguish them in various categories while we design the system, or we talk about the availability of water, what type of water is available in our vicinity or in a certain area. You see, we define that based on the total dissolved solids which are present in the water. And the tap water normally are those which have less than 1,000 milligrams per liter TDS. So similarly, the brackish we normally called 1,000 to 10,000 and high brackish 10,000 to 15,000 TDS. Saline or salt water greater than 15,000 TDS and seawater it is 15,000 and to up to 35,000. Normally, seawater have above 35,000 TDS in all oceans, and the brine solution which TDS exceed from 35,000, those water are called the brines. Freshwater composition. When we talk the freshwater tap water, we observe that it has mainly the chemical composition like sodium and the chloride. That is the main constituent in all type of water. In fresh water having less than 1,000 TDS or slightly brackish water up to having 2,000 TDS, the sodium concentration and chloride concentration always dominate in all type of water sources. And the remaining you can see the sulfate, calcium, potassium, magnesium, nitrate, nitrite, and bicarbonate, alkalinity, ammonia. This composition, when we'll go in the next slide, you will see the concentration of individual ingredients or contaminants, you can say, or the minerals, and that varies. This was the fresh water having a TDS around 1,000 milligrams per liter. Now the brackish water. In brackish water, you see, and if you compare with the previous slide, the sodium was 30% and the chloride was also 30%. But in this case, the brackish water where the TDS are high, above 1,000 up to 15,000, we normally observe that the sodium chloride, again, its concentration is high and the remaining, you see constituents like sulfate, calcium, magnesium, carbonate, bicarbonate, their concentration increases as the TDS increases. Now that we come to the seawater concentration, again see here that we have the chloride and the sodium about 45 and 46% here. When we go to the seawater where I have categorized given the colors to indicate you that the chloride lines are around 55% and the sodium 30.60%. And similarly, the sulfate, magnesium, calcium, potassium, these are the priority parameters which are normally observed in the water, and that is why their distribution has been presented to you guys. And apart from this, we have the barium, strontium, fluoride, iron, and there are other constituents as well which are present in the well water. When from the canal surface water, they all come from the mostly from the glaciers. And you see when they travel, they have the clays and the contaminant. And in Pakistan, especially, we don't have the wastewater treatment plants or the sewage treatment plants, and we are disposing all the wastewater as such in the rivers and canals. And from that, we are again making the potable water, especially if we talk about a Raval Lake filtration plant. From the Raval Dam, we are collecting the water and supplying after treatment to the Rawalpindi and Islamabad area. Similarly, at Karachi, we have a hub nearby a dam from where we have the water supply for our domestic use. We have the Northeast Karachi and a couple of more at the hub as well. Water treatment plants which are taking the water from the hub, the surface water that is stored in the dam again, that will be having more contaminations apart from the which we have mentioned in this presentation. Basically, the water had two type of contamination. One, those which are have suspended form, and other is the dissolved form. The dissolved form, if you see a glass of water and you have mineral water, if you have the mineral water bottle normally has TDS from 100 up to 250 milligrams per liter. And if you see the other waters which we take from the tap having 450 or 1 up to 1000 TDS, you cannot distinguish from the color of the water that how much TDS this water have. It means that those are dissolved. Those types of minerals, they are called the dissolved salts in the water. They are dissolved solids, and the total suspended solids are those which we can see. If you see the river water, dam water, you see there is some sort of suspended contamination coming up, and these are normally visible with the naked eyes. And these again are of two types, which will not, I will try to go further. One is the non-settlable, other is settlable, and in the dissolved solid, volatile, and fixed type, both we will have a little idea in the next slides. These are the total contamination which I have summarized for you to understand. And that on the top column, you see the substances, suspended impurities, colloidal impurities, dissolved impurities, cations, and anions. These are the generally the water composition, which is foreseen in the various sources of water. And you can review that in the suspended impurities, you have the sand, clay, inorganic solids, and the organic impurities, top of soil, ground, or decomposing or organic matters. And then we have sometimes the gases, living organisms, algae, fish, and minute animals. Colloidal, in a colloidal impurities, we have silica, clay, iron. You can review this table, and I will would like to focus on the last two slides, last two columns. Normally, this is the dissolved solids, and people we are using, they are of more concern for our drinking water. Especially, we have to remove this contamination to make the water fit for the domestic use or make it mineral water or it's bottled water or for industrial use like textile processing, sugar, boiler, cooling towers. These are parameter cation anion. These cation anions are basically removed by either by the ion exchange process or the membrane technology. And the impurities, which are the colloidal and the suspended, uh, they are removed by the physical treatment. We have like a filtration in the sand filter, activated carbon multimedia. If we have arsenic or the fluoride, we can use the respective media for their extraction or absorption as well. And for the dissolved impurities, we have to go for the membrane technology, which is very popular nowadays. A companies like Dow, Hydronautics, and other, they are manufacturing good quality membranes for various applications. And we will, in our next, my presentation, which is due on 2:30 p.m. on 5th of November, I will try to cover the factors which are affecting the performance of RO plant and the membrane. And I will also try to cover a little bit how to design a perfect system which can meet your expectation. A proper design of pre-treatment is very much required for designing the RO and the UF system. And we will discuss in the later sessions. Now, effect of various impurities, just because this is a seminar or international conference in which the people from the various segments of the life, they are participating. Some are from the industry, some are from the general public, and some students. They everybody want to learn, okay, what is the root causes, and why we need to treat the water and the wastewater. And just I have summarized for the information of those who are interested to learn why to treat the water. That I have given a slide in which I have explained, try to give you some idea about the effect of various impurities in the water. Suspended impurities, we have the bacteria, algae, protozoa, and clay silt. And you can see the bacteria causes the diseases, algae causes the color and turbidity, clay and silt causes the turbidity. And if we see the calcium, magnesium, they exist as a calcium carbonate, calcium bicarbonate, calcium sulfate, calcium chloride, and these are general. What the industrial causes, root causes, what are the problems in the industry, you will see. Likewise, the sodium, which is present in the water, it is available as a sodium bicarbonate, carbonate, sodium chloride and the sodium chloride. Sodium chloride, and you can see the effects of this various ions present, your molecule present in the water. And these are the metals. Sometimes metals are also present: manganese, iron oxide, lead, and arsenic. These arsenic is a poisonous and carcinogenic as well. Lead also poisoning. That this is also carcinogenic and create life-threatening sometimes. In Lahore, 5, 10 years back, the industries had been discharging the untreated wastewater, and we observed that fluoride concentration in the wastewater, that area was very high, and the newly born babies and the kids below 5 years, they had a problem of bending their bones. And there are we need to address every problem. And one thing important here is to share with my audience and the participants that normally we ask our uh, experts or the contractor, EPC contractors or the water treatment equipment supplier, I need a 10 liter, 20 liter, 1000 liters per minute drinking water plant. And they don't provide any analysis, water analysis. Actually, sometimes you don't need the RO plants. Sometimes you need the ultrafiltration plant. Sometimes you need iron removal or arsenic removal or the selective ion removal. Please, it's my request you to all that whenever you want to plan any water treatment or the wastewater treatment facilities, first get the all parameter tested so that you should know what is the problem, and your consultant or the designer or the EPC contractor can offer you an appropriate solution. Otherwise, uh, they cannot provide the universal coverage to the pre-treatment or the that all type of option should be kept in the treating this water. Better to spend 5, 10 thousand rupees and uh, get the sample tested from a reliable lab existing in your areas, and it will give you the exact idea of what type of a treatment you require, and it will also secure your investment as well. Now, this is the waterborne diseases, and we have the mainly the in water, the bacteria, protozoa, worms, virus, and fungus, and they create the typhoid, dysentery. You can see amoebic dysentery and malaria, yellow fever. These are the microbes which are causing the problem in the drinking water. In the 90s, World Bank carried a survey in Pakistan about to develop and to assess the need of the hospital in Pakistan, and that report is available on the net as well. They observed that in Pakistan, around 60% bed occupancy in the hospital is due to the waterborne diseases. Then they plan that and advise our government that we should focus on our water quality so that your hospital capacity can immediately be enhanced, and when your patient due to the waterborne diseases will not come to the hospital and they will be treated at home, you can have immediately 60% availability of the beds. That's why that clean drinking water for all this project was initiated in late 90s, and till to date, we are unable to execute that project. We couldn't supply the clean drinking water to our society, which is the uh, basic challenge for the government. And we don't want to criticize the government on this project, but I request that they should feel the responsibility that our people need the clean drinking water, at least apart from the other challenges. This is the basic challenge, and so that the newly born babies and our future generation, they can avoid such problem or diseases and have a good health. When you will be having a good health, you can contribute the best to the society. Now we will talk some parameters apart from the TDS. we have the pH scale. You can see, just develop a slide for you to understand what is the pH of various commodities like fruits, vegetable, and the blood. You can see, and normally the pH of water is 7 is considered as the neutral, and the blood has the 8 pH. You would be surprised to see our stomach. Stomach acid has around 1 pH, and our blood has 8 pH. That is you need to learn on it that our various organ of the body has a different pH, and that's the nature how we are operating. Our Allah Ta'ala has made our body that one in a various organ has a different requirement of pH, and that automatically that is built up. Now we need to understand when we operating our system water treatment, and we'll do the sampling or we'll do the testing, and there is a direct link of pH versus temperature. You know, from this graph you can see pH increases as the temperature decreases because we have the bicarbonates in the water, and that is H positive and OH negative, hydroxyl and hydrogen ion. When bicarbonate decomposes, then that results in effect on the pH with the temperature. And there we have the relationship of conductivity because the measurement of TDS, it is by the evaporation process and it takes some time. But in water treatment technology, the direct measure of the TDS, we can correlate almost. If you have the 10,000 conductivity, mean you have the 5,000 TDS. That just a thumb rule for you, and it may vary from a factor of 0.5 to 0.7. That depends upon the ionic composition of that sample. It is just for your reference that in water treatment we correlate the conductivity and TDS as well. And here you see, this is again, that was for the previous slide was for the high water conductivity. We had a millisiemens per centimeter, and this is for the lower water TDS. And you see the behavior is almost same. And if you see the left side conductivity table in a color table, you will see that 15 degree, 20 degree, 25 degree. Normally, we take the 25 degree as the standard temperature for the measurement of all um, laboratory testing. But one thing I assure you that if you take the sample of the water, especially for the RO product or the drinking water, its pH is very unstable. If you take it if you measure online, the pH will be different. If you take it to the lab, the pH will be different because water absorbs the carbon dioxide from the air, and it's make the carbonic acid, and which lead to lowering the pH, and this will be different. And it is better always to measure the online or the flowing water pH at duty point, and you can have a beaker and keep the water flowing in that beaker and put the electrode in that, and then you will be having a representative pH of your stream. Similarly, an oxygen is an important factor which is present in the water. Normally, in the fresh water, around 6 to 8 milligrams liter oxygen is present in the water, which is very much required for the aquatic life. And the fresh water, this is a graph for you better understanding at the various temperature. You see when at low temperature, the oxygen concentration come to the zero, and you will see that we have for the seawater, we have around 11 milligrams per liter oxygen, and for the fresh water, we have around 40. But as the temperature increases, the oxygen concentration in the water, it decreases. You see, at the 50 degrees centigrade, we have around 5.5 or something like that. For seawater and for freshwater, it is 6 maximum. Hardness, a little bit hardness because another important factor for our industrial use, especially is the hardness or the domestic use. Even we see that scale formation occurs in our taps and the lines in the home where we are using the water, and that is mainly because of the hardness. And similarly, when we go to the industry, we in a various process require specific water, especially when we go for the heat exchangers like cooling boilers and the cooling towers. There we have the scale formation, and we need to keep the surface clean for the fish to have a good efficiency of the boilers and a good efficiency of the heat exchangers, so that we have where the scale deposits, there is no transfer of heat take place or very poor transfer of heat take place. That's why we require to soften the water for our in Europe and America, and even in Pakistan to some extent. It has started the trend that we use the soft water for our residential purpose and normally in industry for the boiler and cooling tower, low pressure boiler and cooling tower. We have the two type of hardness which are present in the water. One is the temporary hardness and other is the permanent hardness. Temporary hardness is mainly due to the carbonates, and permanent hardness is due to the non-carbonate compounds. And major source of scale in water, boiler, cooling towers, you can see I have already explained you. And this is a table which I have shared for your information generally how we categorize the water. Uh, Soft water, actually, different in different countries we have a different measuring units for this hardness, and some if you see on the top, there are ppm as calcium carbonate is a very popular unit in Pakistan and the US, and grain per gallon, German degree hardness, Clark hardness, French hardness. In these, we have the conversion factor. If you see 60 ppm as calcium carbonate, that will be equal to less than 3.5 grains per gallon, and German hardness likewise. And medium hardness, you can see 61 to 120 ppm is the medium hardness, and 121 to 180, that is hard water, and greater than 180 is very hard water. That's the classification of water with regard to uh, uh, water hardness. A little bit on the filtration technique. I have already explained that we have two type of impurities in the water. One is the suspended and other is dissolved. Now, a method of treatment we will discuss. They are separate for the suspended impurities and the dissolved impurities, and it also depends what type of water you require for. If you require the drinking water, we'll be having different treatment scheme. If you have processed water for boiler, high pressure boilers, we require ultra pure water. If you require for the medical, pharmaceutical purpose, every process requires the different type of water, and your designer or the consultant or the contractor has to supply the equipment as per the need of your two requirements. One, what type of water you are having, and the second, what is your required quality for the process. That required quality is given to you by your machine supplier or the process developer. Like in a textile, you will have to see for the dyeing, finishing, bleaching, what type of a water is required. Normally, at the high pressure boilers having 80 bar pressure, they require the conductivity less than zero point zero 0.01 microsiemens per centimeter. We have to achieve that targets by employing the equipment based on the type of available source. And for the physical impurity, what is the objective? Purpose of various treatment is to remove physical impurities, chemical impurities, bacteria, color, taste, odor, whatever is the present, we have to remove to meet for its utility, which we intend to. In these broadly classified treatment, we have For the physical treatment, we have the screening, plain sedimentation, sedimentation with coagulation, like Northeast Karachi project at the Hub River. What we are having, we have a rainfall water, we are collecting in a dam, and then we are doing the coagulation, flocculation, and filtration process, plus the disinfection that is being done. And that all processes employ your screening, plain sedimentation, sedimentation with coagulation, and these are employed on the surface water for the removal of suspended solids. And this technique is very old, and now we are having alternative advanced technologies. We can also go with the ultrafiltration with techniques which require far low area and far low time for setting up the project, and its reliability is higher than this conventional sedimentation system, because you need to have the proper dosing, jar testing, control the parameters, sludge handling, lot of other things you have to manage and to control the process. And then in the ultrafiltration, even the microbes, you don't sometimes need to have the chlorination if your storage capacity is not much higher. Otherwise, you can have a drinking water without chlorination as well. When you do the chlorination of the water, then you have to do the dechlorination through activated carbon filters or sodium metabisulfite or calcium metabisulfite. This is a process which we need to understand. Now, the selective ion removal, we have the beam that reduces the iron and manganese compound present in the water. And we have the sand and gravel filter remove the floating particles suspended solid up to 40 micron. Then we anthracite activated carbon filter. This is their application normally, which I have mentioned in this present. About the sand filter, how to design the sand filter, and you will get the idea multi-layer there, how much velocity we have to get and what size of a particle they remove. And this is a multimedia filter. You can see have multiple medias that depend upon the application, that what we have to do with that. Now come to the ion exchange technology. Dow is the leading company in the ion exchange technology, and Dow now has been acquired by the DuPont. And initially, it was Roman Haas who developed the technology, and Roman Haas were acquired by the Dow, and Dow now has been acquired by the DuPont, and DuPont is now our channel partner, and we are having a technical collaboration on their products and the technology. They offer the good services and the support to their OEMs, and I appreciate their support. And you can see the ion exchange system we use for the boiler, beverage, soft, and processed water requirements. And this is the ion exchange applications you can see. And in the strong, we have the different type of resin for different applications. You see the resin type I have mentioned. You can review it, and they are different for the different application. And I have given their application base. And now we proceed with the membrane technology. First, we start from the reverse osmosis. Basically, most of the people know the RO plant. It's very popular for the last 2 decades. People are, even layman knows that the RO plant for the drinking water or for every solution, they understand that is we have the RO plant. That's a good sign that our nation knows what is RO. Yeah. Let's talk about the RO plant. Basically, RO membrane is a molecular sieve. Like we sieve analysis we do at the home, like when I will say when we have घर में हम sieve analysis करते हैं, जब हम आटा वगैरह को उसको हम छानते हैं, like that is the pore size of the membrane which define the membrane's purpose of installing or selecting the membranes. So in the membrane module, this is the basic principle. We have the feed water, which is which flows, and we have a product and concentrate streams. On the other side, or from one side, we enter the feed water of any TDS. That will depend upon the design, which membrane we are to select for the tap water, brackish water, or the seawater application. And its recovery depends upon the feed water characteristics. First, we have to treat the water to make fit for feeding to the membranes, because membrane manufacturers, they provide the data sheets, and they define the feed water condition and the cleaning condition on their data sheets, that these conditions are to be maintained for the smooth operation of the RO plant. And you can see one term which we normally use is the recovery of the system. Recovery of the system depends upon various factors. It depends upon the path length of the membranes, the how much membrane series in series you are putting in. And the second term is the salt passage. If you see at the bottom, recovery percentage is basically permeate flow divided by the feed flow into 100. That gives you the recovery of the system. Suppose if you are feeding 100 cubic meter per hour water, and you are getting the 70 cubic meter per hour product, and 30 cubic goes to reject, 70 divided by 100, it means you have the recovery of the system 70%. And if you, other term is the salt passage. Salt passage. Normally, the membrane manufacturer claim that their membrane, single membrane, they are tested on sodium chloride solution, and it has a 99.7 and above salt rejection percentage from the single membrane. But when we put in the system, it rejection goes to, depending upon the path length of the membranes, how much membranes are installed in the series, you can have 1 or 2% salt passage. Salt passage, you can define the permeate salt concentration. Permeate mean product. In product, how much salt you are having, and divided by the feed concentration of salt into 100. This is the two main terms which we normally use in the RO plant. Now, we have a different applications, different type of RO membranes for different application. As I have already explained you, that membranes is a molecular sieve, that a certain part of certain size of molecule can pass, and that depends upon the size. You will see the smallest hole in the membrane, you can say for easy understanding, the particle size is up to 0.001 micron. It is for RO. Then when you go up to the particle size, I want to eliminate particle size up to the zero point zero 0.01 micron, then we will use the nanofiltration membranes. And if we want to go for the zero point 0.1 micron filtration, then we will use the ultrafiltration membrane, and 0.1 to 1 micron, that is a microfiltration, or sometimes people call it molecular filtration membrane or microfiltration membrane. These applications I will explain where what these membranes perform, and why we select membranes of any category for our particular application. This chart will show you comparison of three type of membranes, what they reject and what they pass. Blue line is basically the membrane. If you see the microfiltration membrane, MF membranes, you will see it passes all the water. All the water mean water including cations, anions, monovalent, multivalent, all water will be passed, even virus will pass. The only thing they will retain is bacteria and the suspended solids. I can see that. And same is the case when you go for the ultrafiltration membrane, they will pass the water, monovalent, divalent. Basically, monovalent, divalent mean calcium, magnesium, sodium, potassium, sulfate, nitrite, nitrate, whatever the composition of water is, all dissolved minerals will pass through that membrane on, and virus, bacteria, and suspended solid we can remove. Normally, we observe that 99% virus, up to 98% viruses are removed. Still, we have some viruses in the product water, for which we normally use the ultrafiltration for the ultraviolet light for disinfection if we are going for the drinking purpose. And the reverse osmosis. You can see on the reverse osmosis, as this molecular size is very small, pore size is very small, and that is why only H2O, water, H2O mean water. Water has a molecular weight of 18, 2 hydrogen and 1 oxygen, and 18. And the second biggest molecule in the water is of sodium chloride, means sodium is 23 and the chloride is 35.5. It means that 58.5 is the molecular weight size, which is next to water, is available in the water contamination or the minerals. That is why all the membranes which membrane manufacturer develop, they test on the sodium chloride solution, that how much sodium chloride solution can pass through that membrane, and their efficiency and testing all depends upon the sodium chloride solution. As the water, little bit about chemistry, and in the hydrogen we have the outer shell one, and in the oxygen we have on the first shell orbit 2 electrons, then the 8 electrons, and so the size of the molecule depends upon the molecular weight. Normally we call it as molecular weight cutoff size as well. As the molecular weight increases, size of the molecule increases. That's the basis of selection of membranes, that we select the membrane for a particular applications. From this slide, you can see on the bottom side, you can see the molecular weight: 100, 200, 1,000, 20,000, 100,000, 500,000, and it will reflect you that where the RO membranes are used, where the nanofiltration membrane and where ultrafiltration membrane are used. And you will see the metal ions, they are removed by RO on the first left side, and then the sugar, we can have the nanofiltration, and when molecular size increases up to virus, you see it is overlapping with the nano and ultrafiltration membrane. It means the ultrafiltration, as per the spectrum, ultrafiltration membranes removes 100% viruses and the dissolved organics. This is the spectrum which you can review for the selection of the membranes. Now we come to the wastewater treatment. Wastewater, we have two sources mainly. One is the domestic wastewater, which we use from, and other is the runoff water from the rain, storm water. These are also the wastewater, and the sewage. This is the domestic wastewater, and sometimes in the kitchen we use the detergents, and this is also contaminates the sewage. And the second is the industrial wastewater. In the industrial wastewater, we have the wastewater, especially from the manufacturing industry. Suppose the textile, if they are dyeing, using the dyeing process, bleaching, finishing, they will be having a different pollution loads, and they will contribute to the TSS, pH, BOD, COD, and these are the parameters which are polluting the environment, decaying, creating the deficiency of oxygen in the wastewater. And to save the aquatic life, we have to treat the wastewater so that we can protect our environment. From the pictures which are visible to you, you can see that a polluted tree, how it look like, and a healthy tree, how it look like. That is the only difference is they are having a good quality of environment where they can grow. And even if we treat the use a treated wastewater for the irrigation purpose, for our crops to develop, and it give a good conditions to develop a good yield of the crops. In the domestic wastewater, and we are categorizing the wastewater here in this slide. Wastewater, we have the industrial wastewater, domestic, and stormwater runoffs. In the domestic water, we have a gray water and the black water. And grey water is normally defined the water coming from the bathroom, laundries, and the kitchen, while the black water is urine and feces coming from that. This is the term which is used for the domestic wastewater treatment. In the wastewater treatment, we have a very different techniques to be used. Mainly the biological techniques are used for reducing the main contaminants like BOD, COD. For the physical, sometimes we have to use the physical chemical treatment as well. Like if in textile, sometimes we have in various industries pH around 11 to 13, and we have to lower the pH up to around 8.5 or below that. That condition is to be met by addition of acid into the stream, and so that the pH for the biological system is conducive for the growth of the microbes. We have to basically in the primary treatment and the physiochemical treatment, we are maintaining the conditions for the biological treatment in the irrigation tank, either it is anaerobic or the aerobic. And similarly for the sewage and treatment plant, recycling of wastewater treatment plant, and zero liquid discharge. We will discuss a little bit more in the upcoming slides. The physical treatment is removal of suspended solids. Like if the paper industry, we have a lot of fine fibers, short fibers, which we need to remove from the wastewater. Otherwise, they will accumulate in the system. In the textile industry, denim industry, you see when we have grit, pumic stone, short fibers. Even in textile, we have sometimes short fibers. We have to remove those short fibers by a physiochemical treatment. First, we adjust the pH and the temperature of the most of the time in the industry is more than 60 degrees centigrade. And before putting this wastewater into the biological system, we have to bring the temperature up to 40 degrees centigrade. We have to provide the living conditions to the microbes which we develop in the aerobic or the anaerobic condition. Therefore, it is critically important either we are using the anaerobic process or the aerobic process. In both cases, we have to meet the inlet conditions of the aeration tank, wherein we have to grow the microbes, bacteria, which will digest or decompose the biological and chemical contamination, which is represented by the biological oxygen demand and the chemical oxygen demand. For that, it is a mandatory that we must bring the temperature less than 40 degree centigrade and pH from 6.5 to 8.5 is okay for the growth of the microbes. Either it is a sewage or it is industrial wastewater treatment in both cases. Recycling of wastewater and zero discharge, these are the upcoming challenges which globally industry and the community is facing, because we are running short of the water around the globe, and we need to conserve our resources, precious resources, so that our generations, future generations, they can avoid shortage of water, and they can have ample water to survive. Because if the shortage of water may lead to many problems, I think it will be a problem to each aspect of our life, for drinking, for bathing, for gardening, for agriculture. Everywhere we use the water, and it is very important that our earlier speaker emphasized, that we should use the conservation of the water. And here I would specially emphasize that while we are either we are working in the industry or in the domestic. Like I will give you the example. Even in the morning, we get up and have a toothbrush or do the shave off, and our tap is always open. And if you go in the Europe or the Dubai or other countries, a five-star hotel, you will see they have installed the sensors there that a certain volume will come out, and when again you will put the hands down in front of the sensor, the water will flow. And then we must care of these things. And in Pakistan, I'm also sure that in future, few sets of with sensor will be implemented so that we can use, we can conserve the water. During the car washing, we waste a lot of time in our house, lot of water in our houses. These are the good practices which we have to adopt. In Lahore, especially when I talk, because my company is working around the Pakistan and I have the data of each region and the city, either it is in Karachi or the Landi, Gorangi side, Nuriabad, whatever the areas are, even in the Faisalabad region, I know the what is the water levels in the ground are and what type of a contamination water they are having. Moreover, the wastewaters, they are contaminating and depleting our resources of water as well. In Karachi, especially, I have observed that the drinking water for domestic water lines and the sewage line, they are just crossing each other, and sometimes it is being observed in certain places that the mixing of sewage line is for observed with the drinking water line. That is a very critical because we have the even hospital waste is going inside those drains, and that has the many contamination. We need to work on the situation. I think in Pakistan we have three type of contaminations. One is physical, chemical, and the biological. Physical contamination, like I explained earlier, TSS, they're coming in the sugar industry from the sugar cane. When they extract the juice, they have a lot of TSS. Then from the paper industry, we have short fibers while processing our paper raw materials. Then at textile, we have the high pH values and some processes we have low pH values as well of the waste stream. Some processes generate the high temperature, color, odor, and turbidity. These are the physical parameters which we have to taken care of in our wastewater treatment plant, and they will be basically will be selecting the physical options for the treatment of bringing pH down. We will use the acid or increasing the pH. We will be adding the caustic to bring in the limits which we want to achieve. Similarly, temperature, we in the receiving body even we should be discharging the temperature less than 40 degree centigrade. And same is the case with the TSS and turbidity. On the chemical contamination color, yes, different like dyes, black dyes, red dyes, the textile, which is all chemical, they also lead to the coloring of the wastewater. Some in the various industry, we have fats, oil, and grease. When you see in the refineries, you can see the service stations. There you have a lot of oil in the cooking oil industry. You have the traces of oils present there, and especially in service station. At in DHA at one PSO station, we installed 10 years back a CPI separator for removal of oil from this the wastewater coming after washing of the car. And if somebody want to visit, they can visit the DHA at Karachi. A PSO petrol pump, I don't remember, maybe Kamran I will be knowing the name of that particular point and can guide you that through this CPI separators, plate type, and we are separating the oil. These are in a chemical, we have the chemical oxygen demand, nitrogen, phosphorus, surfactants, phenols, chemicals. Whenever you go into the manufacturing process for the chemical, especially, you are having a lot of byproducts, or you ultimately you will be having some waste as well. And those waste streams are fully contaminated with the pollution load like POD, COD, PSS, and you have to make the treatment for these applications. Whatever the contaminant are, you have to select the treatment as per their requirement. Here, I would like to mention that some of our friends, because WEMS is one of the leading company in the water and the wastewater treatment plant, working in operating in Pakistan, and I proudly claim that in 2001 we are the pioneer in bringing the RO and the wastewater technology in Pakistan. Before that, 99% RO plants were imported, and there was no RO plant was assembled or manufactured here. Although the components were imported like membrane, pressure vessel pumps, you still, I do remember when I sold the first plant of 100,000 gallon at Karachi, the imported plant price was around 110 to $120,000 on CNF Karachi basis. But the first plant which we developed for the same capacity and sold, that was around $65,000. That gave around 40% price reduction and value addition and to the local industry. And now we have many companies, mashallah, they are putting their efforts and they have established their business in the water and the wastewater treatment plant. Still, in Pakistan, we are dependent upon the wastewater treatment technology. We are, especially from Europe and China, we are trying to get the technology. But I assure you, since 2004, we went installed the first plant. Till now, we are having in-house process design engineering capabilities, which is key to our success. We know what is inside, and our all plants, mashallah, by the grace of Allah, and my team is very dedicated. We have installed the plants in the sugar industry, in the food industries, in the textile industries, dyeing, bleaching, printing, everywhere in Pakistan. And we're proud of my team that they work hard day and night and they provide the best services. And our main objective is to design an appropriate system which can meet the customer's requirements. Next, please. In the primary treatment, it is a physical treatment, sedimentation of particles. I have already explained you. In the secondary treatment, we basically, it is a biological treatment to reduce the organic load of the wastewater. Organic loads के biological जो है इसमें we have two options, one is aerobic and other is anaerobic. In both ways we can work on, but that depends which technique is to be opted for a particular industry. Especially if we talk about the distilleries or the sewage, we can just use the anaerobic system there. But for the textile, anaerobic system mostly don't work. They give maximum 15 to 20% reduction of anaerobic in anaerobic conditions. That is why the biological system with the activated stress system, they are used for the textile industry. And in that we have multiple choices for the activated stress system. उसमें जो choices हैं वो we will discuss in the next slide. And then involve the tertiary treatment. In tertiary treatment, we use the chemical to reduce the color, odor, and bacteria chlorination that we do so that the water is safe to discharge or the recycle. Now we come to the wastewater treatment scheme. Generally what the scheme in the conventional system is followed. First, the wastewater stream comes and the screening is done. The objective of screening is that the bigger particles, they should not destroy the pumping system ahead installed in the equalization tank. Then screen water is put into the equalization tank. And here I would like to explain some critical points to my friends who are interested in setting up a wastewater treatment plant for the industry. That sometime I receive the comments from my customers or from the people who want to learn that equalization tank. The objective of equalization tank is very important. This is not the storage. I will give you the example that how to size the equalization tank. For the sake of argument, if you have a vertical textile unit, you will be having some time bleaching, finishing, dyeing, scouring, the various processes you will be implementing, and every and the washing finally. And every process has a different contaminants. When you wash, finally give the wash, it will be low contaminant. It means when your wastewater is entering into the equalization tank, it will have flow variation and contamination variation. Here, if we assume that your all processes of a batch, they complete in 8 hours, then we will design the equalization tank for 10 hours at least, giving the 2 hours margin so that if you repeat any process, it's can be homogenized because equalization tank then gives a constant feedstock and its characteristic flows to the next wastewater treatment plant. Basically, aeration tank is the buffer tank which handles the flow fluctuations and contamination fluctuations of your streams coming in. If you have a continuous a stream of wastewater having the same characteristic all the time, then you can reduce it to 2-3 hours. It will reduce your civil cost. Then it will go to the primary treatment, wherein we will put in the uh, polymers, pH adjustment before that, to remove the suspended solid and from the bottom, and we will take it to the sludge drying bed or filter press or the belt press or the sludge drying bed. And from this, when the suspended solids are removed or minimized, then we take it to the aeration tank. In the aeration tank, we have the some time use the surface aerator, but fine bubble diffusers are the best technique in the conventional activated sludge process. And here you see from the bottom, we give the air to the system, the fine bubble diffuse through the fine bubble diffuser and the blowers installed the blower room. And here we develop the bacteria which decompose the sludge, which is having BOD and COD. And then when the sludge volume index increases gradually, when the decomposition of the wastewater goes on, then we have the secondary clarifier wherein we separate the sludge and water, and from the bottom we take extra sludge to sludge dewatering system or sludge collection pit and recirculate the some sludge back to the aeration tank. And in a aeration tank is very important part. This is heart of the system in the wastewater treatment plant, and it's the critical parameter which are defined. There food to microbe ratio. Normally we call it FM ratio, MLSS. Okay, हमने इसमें MLSS कितने रखने हैं, और सीवेज में normally we have 1500 milligrams to 2000 milligrams, and the textile in the conventional, I'm talking about the conventional system, we have the MLSS around up to 3500 milligrams per liter starting from 1500 in denim. We have a 1500 to 2000 milligrams per liter, and if we have a dyeing or the printing units, then food to microbe ratio increases, and that rate will go to higher levels. But if we will talk next, the size of the aeration tank, that depends upon the BOD load, the flow rates, and these are the key parameters on which normally we size the BOD tank, aeration tank. After that, we have the clarifier from which the clean treated wastewater goes to a tank, or it can be directly discharged. The objective of setting up a supernatant tank in the to finally store the wastewater is that you can do the chlorination And ahead of that, you can use the sand filters or UF, and you can recycle the wastewater for the agriculture or any other use which you want for the plantation or for the recycling. We will discuss in the next slide. This is another option for the small the way industrial or the domestic sewage treatment plant. If you review the previous slide, in the previous slide, we had the primary clarifier to remove the DSS, and then we have the aeration tank, then the secondary clarifier. If you see this slide, screening and equalization has the same purpose. This is the sequence batch reactor now, or basically it reduces the volume of the aeration tank to save the capital cost of the complete, and it here we put the packing material or some filling media which increase the surface area of the tank so that the attached growth can be developed, bacteria which are developing in the by decomposition of the POD COD, they can be sustained or retained in the aeration tank by attaching themselves on the media, which gives them the place to stay on. And as the bacteria grows, the biomass grows, and this basically SPR, they are normally used for the industries which have low flows, and especially for the sewage treatment plants, small, for the hotels, schools, like that. We have a sequential batch reactor, SPR. This is another application. This is the one tank. This is which is using all the steps in one tank. First step is fill the water. Second is aerate or mix. Then you will operate the blower in second step. In third step, you will, after giving the mixing air and homogenizing the effluent and meeting the air demand, we check the dissolved oxygen levels, and then the sludge develops, and then we just put off the blower radiation so that no more mixing should happen, and sludge should settle by gravity. And after 20 or 30 minutes, depending upon the process control, we see for the various applications, there's a different time required for the settling of sludge. And then from the top, we remove the top clear water, and treated wastewater is disposed of. This is another application for the small systems which is practiced even in Pakistan. This is the moving bed bioreactor, another technology. It is also basically the activated sludge process. Now we come to MBR technology, which is I think our latest technology for Pakistan, and which people are using. So a few projects that I have observed at Karachi, they have installed the recycling of wastewater treatment plant. And now this will be more interesting for the industry. This will be more interesting for the industry who are setting up the new wastewater treatment plant. I have two options. Let me see. Yes, this is first. We should emphasize on this slide. If we already have the wastewater treatment plant installed at any premises, then we have to install ultrafiltration membranes or the system to remove the suspended load of contaminations, and its objective is almost 80 to 95% recovery we get from the ultrafiltration membranes. And we, by incorporating UF membranes, the UF system, the objective is to make water fit to feed in the RO plants. Every RO membrane manufacturer, Mr. Dimitris, I think is on the line in listening my comments as well. He will explain you on this, that every product, every I mean membrane, ultrafiltration, RO, or any equipment, even if you buy a car, it gives you the operating conditions. Okay, after how much time you have to change the oil, which type of fuel you have to use in everything like that. Every product has its data sheet for the membranes, and they define what conditions are to be met before feeding the water to those skids. Suppose if we are setting up the RO plant, we need to comply with the feed water conditions. Okay, what is the source of water? What contaminants are there? The well-designed pre-treatment only can lead to the reliability of the RO system. Operation maintenance will be reduced, and you can enjoy your life if you have a good pre-treatment, well-designed pre-treatment that only can be designed if you provide the detailed analysis to your vendor or the EPC contractor or the membrane manufacturer. Because like a doctor, the technologists of the water treatment, they also observe from the data that what contamination can damage the RO membranes, what contaminations can damage the UF membrane. Now, if you see here, we have to first achieve the process control of the wastewater so that we can make water fit to feed to UF. And from the UF outlet quality, we have to ensure that water is fit to feed the RO membranes. Those all are integrated system parts. And we have to meet the feed water conditions for all. Now I go back to in this case, when you have the existing system, you see you will have to install after wastewater treatment UF and RO for recycling of wastewater. And if you are setting up a new facility, okay, yeah, yes, then you don't need to put a UF. You have to a modified wastewater treatment plant based on activated sludge process, and you will put a instead of secondary clarifier, you can say it's not true, but for your understanding, I'm just explaining that you can put a MBR. These are also the membranes. And what happened is that this membrane give you the return slides much. And in conventional system, you can go for the in the aeration tank, you can maintain the MLSS up to 5,000, 4,000, maximum 4,000. And by incorporating MBR membranes, MBR, these are of two types. One is a submerged, one other is the outside dry. And pros and cons of both submerged membranes are different, and the one we were placing outside, they are different. And people prefer to avoid submerged membrane as maintenance of the system is easy when it is outside. In MBR, what we do is we increase the MLSS ratio up to 8,000 to 12,000 in the wastewater, but the cost of membrane is much high. And for the new facilities, you can go for the MBR based technology combination, which will give you the direct feed water condition for the recycling of water through RO plant. In Pakistan, basically, we have these liquid discharge standards. You can see the priority parameters, which are we normally observe for the liquid. And you see the NEQS mean National Environmental Quality Standard, which has now been is a provincial subject. And if we talk about the steel industry, they will use the SEQS. And if we talk about the Punjab, they will say PEQS. After 18th Amendment in our Constitution, this basically changes occurred. Originally in 1997, when the NEQS were developed, they were for the national under the Ministry of Environment, which was under the federal government. And now BSR and Z the HC standard, they are being followed for sustainable industrial growth. And these standards basically don't belongs to Pakistan. They are the international standard which buyers in textile industry, especially, they are focusing, and World Bank, IMF, they are basically finally leading toward these standards. Unless we achieve these standards, even we cannot recycle the wastewater. Otherwise, membrane replacement frequency will increase, cleaning frequency will increase, and that will lead to a greater OPEX and CAPEX.
The first question is it possible to you to give us composition of water that can be used for showing laundry and car washing, etc. Right now, we use potable water for all other users. We can plan to minimize water treatment of water, domestic use, and provide domestic plants and kitchen and drinking use. Nahid Ghazanfar.
Yeah. This application basically soft water is used for the washing the laundries and the showering. Soft water is used. You have to remove. First of all, it should be the tap water less than 1000 TDS, and then it should be softened water, because calcium and magnesium and iron, these must be removed. When we do by the ion exchange process, we remove the calcium, magnesium, and iron. This soft water basically create the stains on the cloth, and your soap doesn't dissolve much, and it's most detergent consumption is high when you use the hard water. Similarly, we see when we travel to various area where we have the surface area, so surface water available, like at Karachi. You see, when I used to take the shower in the hotel, and the soap easily spreads on my hairs or the body. When I take it, go to the Lahore, in my own home, it's difficult because the hard water, when already saturated with the calcium and magnesium ions, it will difficult to have its impact or effective utilization, or you can say the efficient use of this detergents.
Okay, the other question is from Blal Aslam that he's saying, as there are a lot of technologies in wastewater treatment, can you just name on the best as per your experience, best mean in term of capex opex?
Best technology. Every application is different for their application. For that depends upon the contamination level. For the textile, currently they are the two main technologies are being used. The convention technology I respect and I rank the top, because in convention technology we cannot afford much capital cost and the operating cost is low. When we go for the MBR technology, and there we have the huge capital cost, and after every 5 7 years you have to replace the membranes, MBR membranes. And to me, the best technology is the conventional technology, which is in Pakistan especially, and the current scenario where there is no problem of the land, and operating cost will be low, and the activated sludge process, and it's the conventional activated sludge process. If you don't have the area available, constraint of the area, like Karachi in various industry have issue of availability of the area for in their premises for installing the wastewater treatment plant, then the MBR is a good technology. If your objective in future is to go for the recycling of the wastewater, and then you can go for the MBR technology. That will be a good technology. You will be avoiding the ultrafiltration and multiple installation of the equipment. We have a good quality membranes in PE or PP and PFD membrane, multi-board membrane, they are available, and Dow, DuPont, and other company, they are having a good membranes, reliable membranes. In Karachi, on a couple of projects, recycling systems are operating, but they are not up to the mark.
One more question, I can take the last question because there are so many questions are there from Artistic Fabric Mills. To meet the ZDHC aspirational parameters, how can we reduce TDS of wastewater?
Okay, one thing everybody must know that wastewater treatment plant they cannot remove TDS. To remove the TDS, either you have to go for the post treatment. You will be using if you have the MBR technology on the wastewater. It's then you put the RO plant for recycling, minimize your waste, and then you will have to evaporate it, or you do it through the heat exchanger, or you can have the evaporation pumps to reduce the TDS, because finally you have to have reduce your waste for reducing the TDS in an effective way, because it's the cost around very high OPEX for evaporating to follow the evaporating process. Can you read, please, Kamran, so that everyone can listen?
Yeah,
Some
yeah.
using the
It's
mobile.
a typical words over. It's a typical words over there. How we can categorize MLSS, MLVSS, TGS, TDS, physical or chemical or biological.
Okay, basically MLSS and MVSS, these terms are used in the wastewater treatment plant. TDS and the suspended solid, they are used in the water treatment plants. We have basically the various testing opportunities. We have a beaker or a funnel. We give them the retention time and check there that there is a proper defined standard ASTM standard through which we check the MLSS and MLSVSS, and that can be shared with anyone. If they have my email address, their cell number, they can send me request me for this information. I will share with them the procedure how to check these points.
Okay. Second question is in MBBR, why media is used? What is the impact of using and benefits of various surface area media?
Basically, in aviation tank, we have to increase the microbe growth so that they can decompose the contaminants like BOD, COD, and other. Mostly, the bacteria which is developed, they remain suspended in the suspension form while we use the aeration tank. But when we put MBBR, any media there, perhaps I will be having something to show you. These are the media which normally, if you can see me, these are the media balls. I don't know if you can see these. These are the balls which we are used in the MBBR, and here the attached growth occurs, and these normally for high pollution load, these filling media are there. And other you can see this one, the bigger one, if you can see these type of available. But for the sewage treatment or the small industry, it is viable solution, and it has also a replacement cost after a certain time. So I will prefer, if you don't have any problem uh, with the area availability, you must not go for the MBBR. Better to go for MBR, or you go for a conventional system.
Okay, another question is from Algeria, Dr. Chabane Mustafa. What is the treatment used for sludge containing toxic compounds?
Basically, we have normally different processes are being followed. Landfills are developed, and those landfills in Europe and America, they are developing. In our developing countries, we don't have even a sludge disposal system. We have to incinerate the sludge. And then what they do is they develop proper RCC ponds, and they put their bags, fill the sludge in the bags, and those bags are put placed in that RCC ponds, and when once they fill, they seal it so that the contaminants don't get again to the environment.
Okay, another question is how we can filter process sludge effluent treatment plant for safe disposal or energy production?
Or we can use a filter press sludge for efficient treatment plant for the safe and disposal. In a filter press, basically, you are dewatering. You are dewatering yeah, and the water from the sludge. Normally, 20 to 25% concentration remains, and other water is dewatered, and you have to dispose it of sludge or incinerate.
Okay, what is the benefit of pre-filter before media filter? Or the same guy is asking about which measure can be beneficial to enhance of life of membrane.
Right. There is a term SDI, silt density index, which reflects the contamination. Just for the better understanding of my, it's a very good question for the related to RO plant. Sand filter, they are used where the suspended load is less than 40 milligrams per liter. Otherwise, we will have to install in the clarifier. And up to 40 micron particles, sand filter or multimedia filter, they can remove those size of particles. If your particle size is less than 20 microns, then after that you will have to install the 5 micron filters. And if even then you have some suspension in water that passes through water, then next you have to install the 1 micron cartridge filter. So that we can remove, you can load the SDI, recommended SDI silt density index is less than 3, up to 3 for the better performance of the membrane. Otherwise, suspended solids, if they are very fine, they will block the membrane spore and you will reduce the efficiency. That all depends. That is why I requested earlier that please a well-designed and proper pre-treatment guarantees the life of the RO or membranes, and it reduces its operating expense by reducing the cleaning frequency.
So the same question from Algeria, Dr. Chabane. What is the equivalent cost of wastewater treatment dollar per square meter? Per cubic meter.
What is the equivalent cost of wastewater treatment dollar per cubic meter? That depends. That depends. So, for the sake of argument, uh, Dr. I will respond you on WhatsApp if you can have my number, because it is different. For the sugar is industry, it is different. For the sewage, it is different. For the textile, denim, printing, dyeing is different. You cannot say thumb rule that this much is the cost for the per cubic meter of setting up a wastewater treatment plant. I will definitely share with you a couple of options. If you have some targeted specific question, please do contact me. My cell number is 0300 842 3103. I will respond you in detail via WhatsApp.